All right, Ken Lane here, API Evangelist, here for another one of my API Evangelist conversations where I bring interesting folks by to talk about APIs and what they're doing. So let's not waste any time. Let's figure out who we got here. Hey there, who are you?
Hey Ken, I'm Dave Shanley. I also go by the name of Quobix, and I'm the founder of Princess Beef Heavy Industries, and I do a lot of stuff with OpenAPI and APIs in general.
Well, it's a pleasure to connect. Been a fan for quite a while of your work, your storytelling, your whole production that you have going on. So let's start before we dive into I think why we got together here. I want to hear the story of Princess Heavy Beef. What's the story of your company? And
Princess Beef Heavy Industries. Yeah,
okay,
it's an interesting name.
excuse me.
I'll give you the short version. I was trying to think of what to call what I was doing, and I was coming up with typical one name things. I was like, this is all very boring and all sounds very common. So whilst thinking for a name, my daughter, who was 2 at the time, she used to watch a television show, and so still around. It's called Blaze and the Monster Machines. It's a kids show about monster trucks, and she used to call it Princess Beef. There's no mentions of princesses or beef in any shape or form in the show, but she used to call it Princess Beef. I'm like, where did you get that from? But what a great name for a band,
Yeah.
Princess Beef. She used to play these toy drums and she called them the honey drums. I don't know why she called them honey drums, but see, I thought Princess Beef and the honey drums. Now that's a name for a band. But I'm too old and way beyond that part of my life now. So I thought, I'll just call the company that Princess Beef. And then the heavy industries part, it's a harken back to my 90s hacker roots. I used to do a lot of stuff in the hacker scene in the 90s. And there was a group called Loft Heavy Industries, and they kind of disbanded in the early 2000s. But they were one of my inspirations for building developer tools, tooling. And I thought, why not revive that name, Heavy Industries? Sounds like, a 90s skater brand. So I thought, cool, why not?
Yeah, I like it. It definitely stands out. It's caught my attention. What I like best about it is visually and narratively, it sets a certain tone that carries through all of your work. I would say, as far as the tools you're building, the imagery, the narrative, and for me, it's I appreciate it because I'm a little different. I tend to be seen as a little outside the normal sometimes when it comes to APIs in the tech space, but it's essential to getting people's attention in this noise and craziness. People just don't notice things, and everyone wants you to be normal. AI, everybody wants you to be the same, and so standing out is like really critical. And doing it in creative, meaningful ways, not just for the sake of doing it, is really important. And that's what kind of brought us together. Is you're kind of at the tip, the forward, I would say bleeding edge, but leading edge of a very political, a very how do I say it? It's where all the power is at right now when it comes to startups, when it comes to enterprises, and it's in the area of API governance, but specifically rules and
Mhm.
what's formerly was known as Specky and then became Spectral once it went into Stoplight. But when I say the business and politics of this, Specky, very good tool, good purpose. There's a lot of energy, interest behind that. It got a little bit more interest as it went into the stoplight realm, and Phil, great guy behind a lot of that. Mike Ralphson behind Specky and some of the stoplight work, great guy. But as soon as something rises to this occasion and becomes more and gets startups and you start acquiring and it starts it it stops being that developer tool, that purposeful. And we're at that intersection with Spectral where I feel like it's useful, it's meaningful, it's a very important tool. It's slow, it's kind of ineffective, it's clunky and clumsy, but it's where the power and startups are kind of aggregating about it around it. But you've kind of said, no, we're moving on, we're moving forward from this with Vacuum, and I want to hear why. I want to hear your story about what's
Yeah, it's a great question. So I'll take you back to the fizzy days of 2019. It's when I started working on this problem. The reason why I started working on this problem was I was at VMware, and I was the architect, or an architect of, and I was the architect of APIs at VMware, or part of VMware. Anyway, the problem was customers couldn't locate APIs, they couldn't use the APIs, they were written by different teams. There were OpenAPI specs, there were WSDL files, there was just a mishmash of Swagger in there as well. Half of these specs were code generated. No one had validated them. The documentation that was generated from them was atrocious. It was PDFs, 500 megabyte PDFs. It was absolutely appalling. So there was just a mess everywhere. There was no standardization. There was no governance. There was no consistency. There was no, standardized documentation. There was nothing. There was no way to know how good or bad anything was. So starting with that problem, I started looking on the internet. It's like, okay, let's go. Just instead of reinventing the wheel here, I'm sure there's companies out there that have already gone and done this work already. So I'm fiddling with my earpiece here. It's falling out for some reason. I don't know why. And I came across Spectral. I was like, great, my problem is solved. I don't need to do any more work. And then I started feeding these specifications from, and these were VMware enterprise products. So they were very large API services, and they were kind of grown over many, many years. So there's a lot of technical debt there. Anyway, I started feeding these specs into Spectral, and it just sat there, just wouldn't return. Like nothing happened. So okay, that's not good. It's not good. This is not gonna work. So when I, finally like cut the specs down, like chopped them down just so I could get Spectral to respond, I realized that this was never going to work in the long run because Spectral has a couple of design problems. Not because it's a bad tool, it's an excellent tool. In fact, Vaccuum it's used the design of Spectral, but I built it in with a different architecture. It's fully asynchronous, whereas Spectral isn't. It can't be because it's built in JavaScript. So if you think about these huge specs and you've got lots and lots of rules, it's running through them one by one, bit by bit, and it just takes for it's exponentially slower. So I thought I'm gonna have to fix this. So we tried. I actually got funding. Went to the CTO of VMware, got funding for it. We tried to build a linter, failed miserably. Had a team of 3 people, couldn't make it work. Spent 3 months on it, just didn't work. And so then we flipped to say, okay, we can't reinvent Spectral. Those guys are geniuses, not going to do it. Let's go and do documentation. So we started building documentation. That's a hot topic now. There's a bunch of startups doing really great docs out there, like Scalar, great docs. So we did this, but it was for scale. So these were 10,000 paths and 100,000 objects, huge surfaces. Built a tool that would read those specs in and actually generate all the content. So, and it actually worked really well. And it was SEO friendly. It was lightning fast. It looks good. It was consistent. So the reason why I started to build Vaccuum was we built a bunch of tooling internally. We started to fix the problem. All the developers started to adopt it because it was great. They weren't force fed it. It's just like, this solves a real problem for us and our use cases. I went back to the CTO and I said, we should open source this. And I don't think I sold it very well, to be honest. The conversation went to, let's turn it into a product. I'm like, no, we need to open source this stuff because the industry is screaming for high quality tooling that just it isn't able to operate at this level. Smaller specs, smaller companies, smaller tool sets, smaller spec. Spectral is okay. It's still slow, but it will do the job. But when you're trying to feed in hundreds of gigantic 50 megabyte specs, it can't do that. It just can't cope. So anyway, that didn't work out. Like the CTO was like, no, let's put it into a product and put it into a business unit. And like, that's not going to work for me. So I thought the only way for me to do what I want to do and do it conflict free would be to exit the company and build it myself. So that's what I did. I quit VMware and I started building Vaccuum from scratch, basically looking at the Spectral source code, seeing what they'd done, how they'd done it. And what I didn't want to do was create a whole new standard, like yet another standard, yet another DSL for describing rule sets. So what I wanted to do was make it a drop-in replacement as much as possible for Spectral. So if you're running Spectral today, you can use Vaccuum and put your specs in or put your rule sets in. It should just work out of the gate within a certain degree, depending how, and I can come to that in a minute of why there's some variances between the two, but mostly it's a drop-in replacement. And I spent about 6 months trying to get it to work, trying to get the whole thing to work, trying to get it to understand circular references. And the more and more I did, the more and more I realized is that I don't just need a linter, I need an entire compiler to make this work. So libopenapi is like it's a Go library for parsing. It's a toolkit for OpenAPI that was born inside Vaccuum. It did all the parsing, had all the models, and what I did is I extracted it out of Vaccuum and then created its own standalone library for anyone who wants to use the compiler to to read, parse, understand, do diffing, things like that, and then continue to build Vaccuum. But it took me a super long time to get it right. I was on the verge of quitting a number of times where I just thought, why is this so hard? And it is hard because the further and further and further you get into OpenAPI, the more complicated, the more the cyclomatic complexity of what you're building becomes almost infinite, particularly with recursive polymorphic data structures and JSON schema. It's like, wow. So I just kept going. And what I noticed is when I just put the code out there, within a couple of months, it was just me. And then all of a sudden, a few people popped up, like Daniel G. Taylor, who's built Humor, and he's also built Restish. Fantastic tools for HTTP tools and a Go framework. He reached out because he was having a similar problem. There was another library out there called, fun enough, Kin OpenAPI. And it's great library, fantastic library, but it didn't support 3.1. To do that, you needed to rebuild the entire library, the entire thing. It just wouldn't work. And what I wanted to do with diffing, like semantic diffing, I wouldn't support it either. So Daniel G. Taylor was looking for some of these features. He reached out to me. We started, I built some stuff for him. He helped me get it off the ground because he adopted it with his tooling that gained some traction. People started seeing it. They started adopting the tools as well. And, all that goodness from that point forward. So yeah, it was what I want to do is parse and understand OpenAPI contracts. I want to build something like the Doctor. We've got a visual experience of managing rule sets and seeing the results, and being able to manage those rule sets. But then, grander visions of what I actually want to do is create a marketplace, right? So you've got your rule sets, and you want to be able to say, okay, I want to share these, and I want to import those. I like those 5 rules from this company. I like these 5 rules. I want to mix and match, create my own shopping cart of governance and save it, and then publish that, and create this new economy or marketplace or community, or however you want to describe it, free economy, obviously, of governance. But yeah, but in order to do that, sorry, I'm going on a bit here. I apologize. I'll pause and let you ask questions in a second. But the order for me to do all that, I needed a compiler, and B, I needed a quality engine, linter. So I needed a linter to work just like Spectral, but I needed to be lightning fast. And there's only a few ways to do that. You build it as a compiled tool using something, well, you could do it in Java, and I was thought about Java. There's a lot of great Java tools out there, but it's very heavy, and there's better tools out there, in my opinion. So I picked Go because I love Go, but you could have done it in C++. You could have done it in Rust. Anything that's going to compile down to native code and run as native machine code is what we need, and not be interpreted like what we have with JavaScript and Spectral. So build that, get it fast, make it really fast, make it really, really fast. And then only then can you start to build the rest of the tool chain, the rest of the stuff. And that's where Wiretap and OpenAPI changes kind of emerged from that foundation, because I wanted to do it real time. In fact, there was a team in VMware that built a web service around Spectral, and it was called the API quality service or something like that. I can't remember the name of it now. It was a very long time ago, but it was. And actually, there's a number of companies that tried to do the same thing. I'm not going to name names, but they run Spectral as a service. Because it's so slow, it can't be real time. So it's submit your job, wait for Spectral to run. You get an email, or you get a callback, or a webhook or something, and we'll say, hey, we're done. And then you get your results and you go and look at it. But it took a huge amount of compute. It was very slow, and it's not real time. You couldn't use it inside VS Code as a, as a linter. It just wouldn't respond quickly enough. So anyway, that's what most companies have taken that approach and realized that it just doesn't scale. That's why Vaccuum's there, and hopefully there won't be a need for another one. If we get to the point where they're, I don't know, you never know what the future holds, and then I'll probably be doing the same thing again in Rust or Zig or I don't know, maybe not C++, but who knows? Who knows what the future holds? But hopefully this should be able to cope with today's workloads for the next 5 to 10 years. Oh, shut up now. Sorry.
No, that's freaking awesome. Like, I can't even tell you. Like, we're gonna need probably 6 or 7 podcasts to go to work through this. Because what you've talked about is like, it's 15 years for me. Like, so 15 years of seeing that exact same what you just discussed with many different players. I'm talking Apogee, MuleSoft, SmartBearer, all of these companies. I could keep naming a bunch, but they're friends of mine, and I don't want to shame them. And they hit the stage with what you did with libopenapi, and then go, well, this has got to be proprietary. We're keeping this behind the scenes. This is where the value's at. And I've seen that happen probably about 10, 15 times where I go, what? You're screwing us here. Like, this is what needs to be out there. And so this is why you ended up with what you have, is because of the business and the politics of the space. And then you touched on the marketplace, the sharing, which we'll get into another. But I want to go back to the DSL conversations, because in that journey, I've seen a lot of people go, well, we're just going to create Smithy. We're just going to create, all these others. And everyone's coming at it from their perspective, meaning I'm an SDK. We need to generate code. We need a complete definition. Our DSL's got to be strict. We're going multi-protocol. We need it to be asynchronous. We're doing docs. We're doing security. We're doing, and everyone's got their, or we're discovery. And so what you came at it from is a pretty, I would say, a much purer and honest, and I don't know, I have to pull out my thesaurus. There's a couple other words I could come up with that are good, but the DSL and the rules, because Spectral is a config file. I mean, that's all OpenAPI is, just a config file.
Yeah,
right? But, it just depends on how many eyeballs, how many people get in and are on the properties and agreeing. That's the scope and the size and the meaning and the purpose of that config file. But so do you feel like, I mean, I've seen you mention you're going to build JavaScript custom functions, or you're thinking about it. I really hope you don't, because I mean, I really hope, I don't, what's your feeling on what you can do with default functions versus that appetite people have for custom functions?
It's a great point. Actually, the JavaScript functions already exist. They've been in there for a while now, so you can use them if you want to.
Oh, you can?
Yeah, you can. Yeah, it's got its own JavaScript engine now. It will execute all that JS. As you can build like Go. The Go plugin system is pretty horrible. There's not much I can do about it. It's part of the language. It will work, but it's not ideal. So that, and also means you've got to compile stuff. So the reason why I built the JavaScript one is because it's dynamic. You can just feed in a script and it will run without recompiling anything, no Go code required. But, I'm not particularly a fan of that. It works, it can be used, but I'm much more of a fan of function-based stuff. So what I like is, like, you've got the core rule set, the core functions, which are things like truthy, defined, alphabet. Those are the core functions. And pretty much, if you can define a JSON path query to look up, that it will work for anything. Those core functions do pretty much anything, and I haven't found the need to add any more. Like, they're Turing complete basic programming principles. Does it exist? Does it not exist? Is it greater than, equal to, less than? So those core functions, I found that can complete the majority of jobs. When there's custom logic, like you want to be able to do calculations on an operation or a parameter or a path or a series of paths, then you need some custom logic, right? So you need to be able to do something. That in that approach, what I prefer to do is build functions. Like, it's a specific function, and I give it a specific rule, and it then becomes like an individual unit. You can say to anyone out there, here's a built-in function, use it, don't use it. It's a rule, enable it, don't enable it. But I always prefer people to stay with the core functions, because They're fast. It works. It does most of it. If you need that custom stuff, build yourself a custom function, and don't do it in JavaScript. Do it in Go, so it runs, at native speed versus the serialization happens with the JavaScript stuff. It will slow it down. Won't be great. But yeah, they honestly there shouldn't be anything that you can't complete with those core functions, and most people just use those core functions. They use the other rules that I've created in there are for additional governance, compliance, things like that. It's it's up to people to use them or not. But when it comes to like expansion, I do want to be able to create a simpler way to put more custom logic in there. I haven't done that yet, but without creating code, if there's a way to create some form of an extension to the DSL that allows you to put some, maybe some rules in, additional sub rules. I don't know. I haven't quite got there, but to be honest, Kin, I haven't had that many people ask for that type of stuff. People seem to be really comfortable writing their own custom rules using the core functions. Or, if they actually are part of the ecosystem, they're actually building their own functions. There's a number of people in the community that are just building their own code, compiling it, and running it with Vaccuum in their pipelines as plugins, essentially. So it depends on how deep you want to go. Now, casual user, use the core functions. Hardcore user, you're going to be in custom code pretty quick.
Yeah. Well, that third dimension, I hit pretty hard at Bloomberg as far as multi-file, multi-version, multi-spec, schema, man. Like there's a lot of multi-dimensional universes where you start needing, I was grouping. So I was tagging rules and then grouping them and then running those. So basically organizing sub rules into groups and then running them and using and building reports like that. So lots to think about there.
Yeah, that's a good point, actually. Something I haven't given too much thought of is projects or workspaces for rule sets and how that applies to multi versions of specs in subfolders and things like that. Yeah, maybe I could tap your brain on that and get some input. You've got some good ideas on it.
I've got at least 4 or 5 other podcasts here because we still got OpenAPI Doctor. We got to dive into libopenapi. We've got to talk about a marketplace. So we've got several other conversations we have here.
Looking forward to it.
That said, we've also got to start a band called Cyclomatic Complexity.
Yeah. Was it going to be like yacht rock, or is it going to be soft funk, or we're going to do some hardcore punk?
Oh, it's got to be hardcore. It's that kind of complexity. That's the noise. It's like yeah.
Okay, yeah, hardcore punk it is. That's good by me.
All righty. Well, I appreciate you coming by today, and look forward to many more of these.
Thanks, Ken. Really appreciate it. We'll talk soon. Cheers.
All right. Cheers.
Bye-bye.
Okay. Yeah, we're going to have Dave back. We got several other conversations. Good stuff. Thanks for joining, y'all.